Welcome to this lesson once again, and we are moving on with our lesson on measurement 1. Today, I want us to discuss this basic physical quantity known as the length. And length is defined as the measure of distance between 2 points. For example, you can measure a distance between, like I said earlier, between Nairobi and Kisumu. That is the length. But length has many examples. For example, now the breadth of a certain object like your desk, the diameter of a ball, the height of a tank, the depth of the sea, all of them are categorized as length. And we are going to see how length is measured. We are going to see the units of measuring length, just like we said when we were looking at the physical quantities. Now, for example, here, we know very well that length, its SI unit is meter. But also, we have other multiples and sub-multiples of length. Of meter. Apart from just measuring length in meters, depending on the how long it is. For example, if the distance is if the length is so small, we will use maybe from decimeters, centimeters, millimeters, and if it is very small, we use micrometers. So we need to be in a position to convert this. If you are measuring a very long distance, for example, you are measuring a distance from Nairobi to Kisumu, you cannot use meters because you will have a lot of figures. But we use kilometers. So all these that I've just displayed to you are the sub-multiples of meter. That is, for example, 1 kilometer is just 1,000 meters, 1 hectometer is just 100 meters, and 1 decameter is just 10 millimeters. 1 meter is 10 decimeters, 1 meter is 100 centimeters, and 1 meter is 1,000 millimeters, and 1 meter is a million micrometers. So I want you to be able to play with these values. You are able to maybe convert from meters to other values, to other units of length, and back to meters using what I've just displayed to you. You can find a simpler way. I know you've learned this even in mathematics in class 7 in primary, so it's not that difficult for you. But be in a position to do so. I will give you an exercise here. Convert the following into its SI units, and I've given you answers there such that after doing so, you confirm whether what you have there is true. Convert the following into SI units. So this means that you have to know the SI unit of length, which is of course meters. So convert 1,000 kilometers to meters. Convert 0.00025 millimeters to meters, 0.01 hectometers to meters, 25 millimeters to meters, 25 micrometers to meters. A simple exercise for you. Now, let's see how we can measure length. There are two ways, or there are two methods that we can use to measure length. There is the one for estimation. We estimate. Then, there is the one that we now measure accurately using measuring instruments. And in this topic, I'm going to state for you 4 measuring instruments that we can use to measure length. And also, I will show you how we can estimate. For example, you may have seen people trying to measure length using their strides. Somebody estimates that 1 stride is equal to 1 meter, which is merely approximation. Why? Because your stride can be more than a meter, or if you are a short person, it will be less than a meter. So it's a estimation. But we have now the one that we use instruments to measure length. We call it now the accurate measurement. We have 4 of them. We have a meter rule and a half meter rule, which we are going to discuss here in this topic today. We also have tape measures, and we have 3 types of tape measures, which we shall use it. Tape measures are used especially when you want to measure a very long distance. We also have vernier calipers, which can be used to measure a short length. For example, the thickness of your hand bump, the thickness of your textbook, the thickness of a meter rule. Then we have now the micrometer screw gauge. This one measures in millimeters, and it measures very small length. Vernier caliper measures short length. This one measures very short. And vernier calipers measures in centimeters, micrometers. I've said it measures in millimeters. So that is it. But now, vernier caliper and micrometer screw gauge, we are going to discuss it in Form 2, when we will be looking at Form 2 syllabus measurement 2. That is when now we will check in details about vernier calipers and micrometer screw gauge. But in our case today, we will check on meter rule and half meter rule, but just meter rule. Half meter rule is just half of a meter rule. So tape measures we will also see today. Now, before we look at the meter rule, there are two factors that we always consider when choosing an instrument for measuring length. If you want to measure length, for example, you have to first of all make a decision which instrument am I going to use, whether to use micrometer, screw gauge, vernier caliper, tape measures, or meter rule and half meter rules. Number one, the size of the object to be measured. If it is very long, for example, you want to measure a football field, you will not use a meter rule, you will not use micrometer, screw gauge, you will not use a vernier caliper, you use a tape measure. And to be specific, the surveyor's tape measure. The other one is the level of accuracy required. If you just want an approximation, you can even just use any meter, any instrument. But if you want the most detailed information about the length, then it means that you have to choose the right instrument for measuring it. Now let's look at meter rule. First of all, meter rule is simply the length of a meter rule is 1 meter from the beginning to the end. For example, here I have a ruler. I don't know whether you can see it somewhere here. So you see, this point is the beginning, but now because this one is meant to be used by students, it's just a 30 centimeters ruler. There is an allowance. The zero starts somewhere here. Then we have an allowance for there and where, or where and there upper. But a meter rule, the zero starts at exactly the end. So the length of a meter rule is just 1 meter. For a half meter rule is simply half a meter, which is 50 centimeters. The other one is simply 100 centimeters. And it can measure both in centimeters and in millimeters. If it is in millimeters, it measures up to 1 millimeter. That is, you cannot get 1.5 millimeters using a meter rule. The calibrations or the marks that have been placed or made in a meter rule cannot allow you to read beyond or less than 1 millimeter. That is, you cannot read 11.5, but you can simply read 11 millimeters, 12 millimeters, 13 millimeters, but you cannot read anything less than a calibration of 1. But when using now the site calibrated in centimeters, that is when now we can read even up to 1 decimal place. You can get 11.1 centimeters, 11.2 centimeters, 11.3 centimeters, and so forth. So 0.1 centimeters or 1 millimeters is what we call the accuracy of the meter rule. Accuracy, in simple terms, is the smallest length a measuring instrument can measure. When measuring centimeters, you cannot get a value like 6.25. No, it's wrong. You just get 6.2, 6.5. You cannot get up to 2 decimal place when using the scale on centimeters. That is the accuracy. Even when writing down the length, you have measured your length and you got it to be 15 centimeters. Just to respect the accuracy of that meter rule, you have to write 15.0 centimeters. That 0 is very important. It tells you, or it tells whoever you are giving that information, that it should be 0.0 centimeters. Yes. Now, so you have to put it in the correct value. So I'm just giving you here what it means, the accuracy of a measuring instrument is the smallest value that can be accurately obtained using the instrument. Now, when using a meter rule, you see, when using a meter rule, there are some procedure you have to follow. We have 3 of them. If you don't follow, you will get some errors. You will not get accurate readings. For example, the first one, place the meter rule in contact with the object whose length is to be measured. You just enjoy it is in contact. For example, if I want to measure the length of my phone here, what I do, first I ensure the rule is in contact with the object that is now my phone. I just make sure that that's the first step. The second step, place the end of the meter rule against place the end of the object that is, which is now my phone, against the 0 centimeter mark of the scale. So I will have to see where is the 0 mark that is at the end of the phone. Mali simu imeanzia hapo. That is where now the 0 centimeter mark. Then that is the second step. Now, lastly, position your eye perpendicularly above the scale. This is the scale. I have to put my eyes above it, not slanting position. It is above it this way. Then I just say the length of my phone is 14.1 centimeters. So those are the procedure that you are supposed to follow. First, ensure they're in contact. Number 2, ensure that the 0 centimeter mark is aligning with actually the end of the object to be measured. Then you position your eye perpendicularly. If you don't follow these 3 procedures, you will get some errors. I'm just giving you there an illustration that you can use to see it about a meter rule. You have to view correctly this point correctly this way, not from sides, because if you view from sides, you will get some errors. Now, sources of errors when using a meter rule. These sources are actually the first one that we have just seen. If you don't follow the 3 procedures, you will obtain errors. When using a meter rule, an error may arise when the rule is not in contact with the object. When the rule is not in contact with the object. Remember earlier we said, the first procedure, ensure the rule is in contact with the object. The end of the object is not aligned to the 0 centimeter mark of the meter rule scale. If you don't align, you will still get errors. Now, if the position of the eye is not perpendicular to the scale, you will still not get correct readings. Look here, the error that occurs when the position of the eye is not perpendicular to the scale is called parallax error. Parallax error is an error obtained or error that is there when the position of the eye is not perpendicular to the scale. So here with me, you will do it for me. We have R1. Just try to find the value of R1 here and consider the accuracy. We have R2, also consider the accuracy. R4, R5, R6 and R7. Just try to give the readings. You can zoom your screen. Just zoom the screen and you are able to get those readings. Yes, so then the answers are just here. You will confirm whether you've gotten it correctly. When I was giving out these values, I considered the accuracy, so it's well. Then after getting it, because you will get it in centimeters, convert them into millimeters and into meters. Yes, that is it. There is a precaution that we are always supposed to consider when using a meter rule. The care that you are supposed to take when using a meter rule. As I told you earlier, meter rules do not have the allowances at the end. Just the end is where the 0 centimeter mark is starting. This ruler, for example, has some allowance because they knew it will be used by students who are so careless. And so what they did, they give an allowance so that when it undergoes wear and tear, it will not touch the calibrated parts that measures the length. But now meter rule, the end is where the zero starts from. That is the point. So care should be taken to avoid damage of meter rules. Yes. Now, I think I will check on tape measures today. Then we are done with length. I mean, we are done with meter rule. We are not yet done with length. Then, so tape measures, we have three of them. We have the Taylor's tape measure. This one is when you are going to know how the diameter of your waist, your length, your chest for your shirt to be made. Now we have the carpenter's tape measure. When a carpenter is building a house, he will use a tape measure. Surveyor's tape measure. Some of you will be surveyors in future. You will have your own tape measures that you will use to measure relatively long length. So the choice of tape measure depends on the nature and length of distance to be measured. Yes, it depends on the nature and length. You cannot use a surveyor's tape measure to find out your measurements for you to receive some clothes. No. We use Taylor's tape measure. Precaution is ensure it is very taut. Taut is a physics word that means very, very tight and very straight during use. Yes. So those ones are just the three things I wanted you to know concerning the tape measures. So let's continue with our lessons. This is our third lesson and we are aiming up to 150th lesson. So enjoy those few concepts. See you in our next lesson. Thank you.